Take a look at the sentence. The artist painted the portrait of a woman with a brush. If you ask the question, who is holding the brush, a narrow-minded model might arrive at only one interpretation. One attention head might conclude that the artist has the brush, while another attention head might conclude that the woman has the brush. Both interpretations focus on a single possibility rather than considering the full picture. However, a model with multi-head attention can capture multiple interpretations simultaneously. It can recognize that the sentence is ambiguous. The brush could belong to the artist who is doing the painting, or it could be a brush held by the woman depicted in the portrait. Natural language is highly ambiguous. To understand different perspectives, we need an open-minded model, one that can examine the same sentence from multiple angles and consider several plausible interpretations at once.
Natural language is often ambiguous. The same sentence can have multiple valid interpretations depending on how we understand its structure. Let's look at an example. Consider the sentence, "The artist painted the portrait of a woman with a brush." At first glance, the sentence seems straightforward, but the phrase "with a brush" can be interpreted in two different ways. This sentence has two valid interpretations. In the first interpretation, the artist is holding the brush and using it to paint the portrait. In the second interpretation, the woman shown in the portrait is holding a brush. The words are exactly the same, but the meaning changes depending on how the phrase "with a brush" is attached to the sentence. In version 1, "with a brush" describes the action of painting. The phrase modifies the verb painted and explains how the painting was created. In other words, the artist used a brush as a tool to paint the portrait. Adjectival attachment woman holding brush. In version 2, "with a brush" describes the woman in the portrait. The phrase modifies the noun woman rather than the action. Here, the meaning is that the woman shown in the portrait is holding a brush. Notice that the words in the sentence never changed. What changed was the underlying structure of the sentence. Humans can usually resolve this ambiguity using context and world knowledge. For large language models, understanding multiple possible interpretations requires mechanisms that can focus on different relationships within a sentence. This is where multi-head attention becomes important.
So hey everyone, welcome to this video, and as you saw in the previous presentation that the artist painted the portrait of a woman with a brush, this sentence is has different perspectives. So how do we combine these perspectives in using multi-headed attentions? Before we go further, I'm just going to take this sentence and show you through how we convert it into an attention score. We have already discussed this in previous lectures, so we are just giving like an overview. So we have a sentence, and for example, I've just taken an example sentence, and then we pass it through input embeddings and then through query key value weights that give us query key value matrices, and using these matrices, using the attention formula, we multiply the query matrix with key transpose and we get our attention scores. We scale them later on, but this is how we get the raw attention score. So if we take an example of our whole sentence, so we have a whole sentence, the artist painted the portrait of a woman with a brush. If you look at it, we have mapped the attention scores for it, and we have mapped which attention scores are the highest. So this is the basic way of getting the attention scores. Now this is the way, but what if instead of using one LLM, we give the same sentence to two different LLMs, and we compare the attention scores we get from both those LLMs. So let's do it too in our next slide. Right now we just highlight, we just create a heat map of the attention scores, which token we are giving the most attention for each token. So this is self-attention, and which tokens have the highest attention. So what if we pass the same sentence to two different LLMs? How do we, what do we get? So like the previous presentation, we get heat maps, we get two different heat maps, because this time both the LLMs have tried to given attention to different tokens. And as we saw in the first slide, in the first presentation, that the problem is about perspectives. So these two LLMs contain different perspectives. The first LLM is giving more attention to the object that artist has the brush. So according to the first LLM, the brush is just an tool. So it is giving more attention to woman and to the artist. But if we go to the attention score 2, which was given by a different perspective or by a different LLM. So here you can see the woman is giving more attention to the portrait and to the brush. This token is giving more attention to both of this, meaning that woman is related to the brush as well as to the portrait. If we look at this from this perspective, it means that the woman is holding the brush in this perspective. And brush, is giving more attention to woman. So it is related to woman. It is not just an instrument here. It is also related to woman in some kind. As we saw, we can get different perspectives from different, LLMs. But what if, we try to give different perspectives in the same LLM? Instead of giving input and trying to get a single perspective, what if we give the input and we get different perspectives? It's more like, the LLM will have multiple heads, like real heads, real minds. Like it's thinking as a group, not as, a single minded person. It should be more open-minded. Our LLM should be more open-minded and should entertain more perspectives. So how do we achieve this, inside the same attention system? So let's take a look at how we implement multi-headed attention. So finally, we are going to apply multi-headed attention, and the idea is very simple. So first, like before, just convert our sentence into input embedding, and based on we have some 11 words, and each word will get 8-dimensioned vector. So how do we apply this? The idea is very simple. We take our weights, the weights for query metrics, key metrics, and the value metrics. The idea is to take our query metrics, value metrics, and key metrics weights and split them in the number of heads. For example, we want 2 heads, for this example, we want 2 heads. So we are going to split our query, key, and value matrices into equal 2 halves. Okay. So we take our query matrix, which is 8 by 4, and we're going to split it into 8 by 2 and 8 by 2 matrix. So see this split, we applied this split on key metrics and as well as on the value metrics. When we are done with this, we get 2 heads. We get weights for 2 separate heads now. The next step is to multiply this input embedding with different heads as we created, So we, just like the previous attention mechanism, we just simply multiply with each query, key, value matrix, and we get our attention scores for each head. So basically we got two separate attention scores, and these attention scores are 11 by 11 dimensions, which you can understand because our query matrix was 11 by 2 and our key matrix was 2 by 11. So we get a 11 by 11 score, which is similar to what we had, even without multi-headed attention. So you can see, the head 1 attention scores and the head 2 attention scores metrics both have the same dimensions. This is necessary. The reason I'm telling you this, it will come handy later. Okay, so the next step now is to combine these two head attention scores. So for that, we have to, process these attention scores just like a normal attention mechanism. We divide it with the key matrix dimensions. We take a softmax on it. And one more step we do that was not included in self-attention was, so what we do is basically change the attention scores to 0 for the future tokens. The scores for the future tokens are converted to 0, and it is very easy to do. What we just are doing is draw a diagonal and take the attention scores of the upper half to 0. As you can see in the these white little dots are 0 scores. So we just draw a diagonal between the attention scores and we change it to 0. This is called causal attention. The idea is we should not be able to see the attention scores for the future tokens. And the next step is very simple. We take the heads attention scores and we multiply it with the value matrix scores. So that leads us to head 1 and head 2 context matrix. Now this is a contextual embedding. The whole process is almost complete, but the final step is to just simply combine these two heads. Now we just combine the contextual embedding for both the heads and make a single contextual embedding matrix. And now this matrix has the multiple perspectives. This matrix has multiple perspectives for the same sentence. Okay, so we have encoded multiple perspectives into our contextual embedding. That is the idea of your multi-headed attention. It also knows about the version 1 where the artist has the brush as a tool, and this embedding also knows about the version 2 where the woman has the brush inside the portrait. Now we are able to put different perspectives into a single contextual embedding, which makes our model more open-minded and more able to see the reality and different perspectives. So this is all in multi-headed attention, and thanks for watching this.